Do you guys even remember 30 years ago when I started this project? Sadly, the day job prevented me from making full use of my time since the last video. Blah blah blah, Patreon, blah blah blah, full-time game dev, whatever. Let's get to it. I think I just really need to hurry to a point where I can give people a real demo of what I'm trying to do here. So instead of chugging away until I finish the game someday, and since my day job constantly messes with my ability to focus on blasting out large, comprehensive systems, maybe the best thing to do is to focus on a minimum viable demo, then throw that up on Steam, hopefully build a bigger following, and figure out how to recruit help from there. Maybe that's a bit of a pipe dream as well, who knows, but it feels like it would be a better shot than just working by myself forever. So I guess that means I'm announcing shifting my focus to completing a smaller scope demo first, with much more limited customizations just to start. Why now? Well, I recently received some comments on an old challenge project I did back in the day to get more familiar with Unreal. It was a stupid simple little game where you could run around and hunt some deer. I had completely forgotten about it, but those comments kind of stuck in my brain for a few days, that even if just a few people saw that and found it worthy enough to download and try for a few minutes, and the hunting crowd is also likely to have overlap with the gun enthusiast crowd, maybe a little hunting module teaser would be a good lure for people to try it and see that it's more than just a hunting minigame, without me having to explain the full concept. So that means the next goal is to get a maybe somewhat simplified version of the builder done, and then start designing hunting missions that force you to build different weapons for, let's say, weather conditions, targets, hunter capabilities, a buyer's needs, that sort of thing. The other thing I have to announce is that I want to make it easier to work on the project and keep you all up to date more often. Now, I'll be the first to say I know my videos aren't keeping anyone on the edge of their seat. So you might be surprised to know that I do actually try to make these videos watchable. But no more. Going forward, I'm going to see what happens if I try to blast these out with as little effort as possible. Who cares if anybody knows what the heck I'm talking about? I'm just going to be logging my dev, and you guys can deal with it. Alright, that's probably a bit too far. I actually do find it helpful for my own understanding to take the time to explain things more plainly for these videos. But I am going to try to allow myself to put less effort into the video production aspect, if you can somehow believe that. And now that I've announced I want to make even worse videos, is the perfect timing to mention this video's sponsor. Previously, I hadn't tried out JetBrains IDE much yet, and primarily used their plugin in Visual Studio. But recent Visual Studio updates are kind of messing with my ability to work effectively, so I started experimenting more with JetBrains IDE, and it's definitely piquing my interest. JetBrains has graciously decided to offer year-long free trial codes, so any of you devs out there can see how you like it as well. I'll put 2 codes in this video, and then a few days later I'll post a couple more in the comments to try to be a little more fair to the latecomers. Now on to the status update portion of the video. I cleaned up the logic about how motion filters are applied, which nobody remembers what that means. Refresher: motion filters are used to help me detect which motion solver to run based on where a part gets hit. Or they were used for that, but I was actually able to eliminate using them entirely by simply adding a priority order to solvers. So now we can check which motion solvers are relevant quickly by seeing how they would constrain the hit. By default, a motion solver will return a 0 delta, meaning the motion is completely suppressed. This way, a rotational type solver can constrain a hit coming in from the side differently than the slide type solver, which is also on the bolt. The slide solver rejects the side hit by constraining the motion to 0, since that hit is completely in the wrong direction. And then we'll check the rotational solver, which is looking exactly for hits in this direction, so we get a non-zero value for the motion. This is also a bit more elegant than what I had before, because it means when a solver hits the limit on the range of motion it allows, we can just use the same code to keep checking any other solvers on the part to eat up the rest of the motion. Now, this is almost perfect without filters, but there's technically still a chance that something hitting the bolt from the side, but not on the actual ramp, could cause a rotation. And so there's still improvements to be made here. This is because the rotational solver is implemented like a lever, regardless of the shape of the actual part. I was also able to try scaling down my source models again, after I found out one of the parts had a very small Z offset on its slide, which was causing extra collisions for the tight-fitting parts around the bolt. This is cool because it means I can trust UE more and verify that I'm the one being stupid. Yay. Well, except for the fact that the whole reason I didn't know there was a very small Z offset was because the BP editor hid the actual value and just rounded it to 0. I also fixed the parenting issue I mentioned in my last video for the rotation sweep algorithm, which I can't really demonstrate yet, but I'm sure it's totally going to just work when I actually end up needing it in 3 years. And once I got all that sorted, it was time to see if the new engine version was going to break everything. The plugin I used to generate my ballistic charts is no longer maintained. So I had to go through and figure out how to update that for a few broken engine APIs, but otherwise the upgrade went super smoothly. Originally I was updating to 5.6, which was the latest at the time, but actually before I finished this video, I also finished updating to UE 5.7.1 as well. Then, like I said in my last devlog, I wanted to try the Chaos Visual Debugger to see if that would help me sort out some of the crazy timing issues I was seeing. Short answer, no. It was a big laggy mess trying to do way more than I needed it to do, and the interface was pretty terrible to get at the exact thing I really wanted to step through. So I started working on my own Chaos Visual Debugger. Well, it's really just the builder and the simulator the players will use. So feel free to give feedback on aesthetics and overall setup or whatever. Everything about it is probably going to change anyway, but what would you guys like to see in the builder mode? I don't really like any of the builders I've seen in other games, but I'm still not 100% sure exactly what I want this to look like yet. The first challenge was actually how to let the player click on a specific component. Wait, easy, right? What, this guy doesn't even know how to click on things? Well, the real issue here is that the way you would normally do it, you can only click on the thing that is closest to the camera, which if you didn't know, almost all the parts of a gun are on the inside, which is why I have this cutaway shader, but shaders aren't real. The collision for the outer parts is still there. So how can we have it so we can actually click through these cutaway parts? Well, what I ended up doing was getting all the parts that are under the mouse, then I assign a unique ID to a variable in the shader. Whenever this variable is non-zero, the shader will render the part as an unlit, flat, single color unique to that ID. Then I render the same scene the player sees, but using this single color shader only, into a background image. Then I map the mouse coordinates from the player's screen onto that background image and read the color at that pixel. That color will match one of the unique IDs, and now we know exactly which part the player actually wanted to click on. All of that just to click on the thing that you're looking at. Now, clicking on things is great, but it's not exactly that interesting if nothing happens. So I decided to implement a right-click menu for the player to do whatever it is they're going to do. If you've never made UI with Unreal Engine, I envy you. It's really not fun. So I had to figure out a way to make it fun. First, I set up a system so I could make any size round radial menu that automatically fits and places any number of buttons according to a set of parameters I can quickly tweak, and stays the same size on screen regardless of the game's resolution. Then I was really confused why the built-in UI animation system doesn't seem to work for buttons you create at runtime, so I built my own UI animation subsystem that basically works the same as the timeline nodes in regular Blueprint scripts. Now it's really easy to add new functions by creating buttons for whatever I want to be able to do. Almost. If I left it there, I would have ended up having a giant switch statement and have to use F names everywhere that could easily get misspelled, and then that would be a nightmare to figure out why the logging button isn't triggering the logging case for some reason. So now I had this grand idea of a data-driven menu system that would be able to bind all the names, icons, tooltips, and translations together for each button according to the type of part the player clicks on. We can throw all of that into a data table for each part and then have one big data table that combines all those data tables, but that's still a lot of maintenance and I could still easily type something wrong somewhere. Enter meta tag. You can actually set any custom meta tag on a C++ class. I don't think there's any editor for Blueprint classes, so then I had to make an editor widget that finds all the classes in any module and lets the user add the menu item meta tag to any class, including Blueprint classes. Now, I can simply tag any class as a menu item and register it with my data table in a few clicks. And since I set the value of the menu item tag to be a unique GUID, I can even rename classes without having to go update the data table entry. Cool. But did you notice that I never mentioned putting the function the button is supposed to do in the data table? Well, we can't really get to function pointers or delegates easily from data tables or blueprints, or at least I couldn't find a standard way to do that in Unreal. So, yet again, time to get my hands dirty. The first thing I did was create a serialized callback struct, which can hold a reference to any class and the name of a function. Then I implemented a library function, which takes a serialized callback and an instance of an object. The function casts that object as the class listed in the serialized callback, then uses Unreal's Reflection API to search for a function matching the name stored in the serialized callback. Then, if it finds a matching function, it calls it. And there we go. Now we have a totally data-driven dynamic menu system where you can never misspell anything, and you can even get a nice little drop-down list of all the functions you're able to call, which is also something I had to implement myself using property type customizations for the serialized callback struct in the data table editor. I was going pretty fast doing all this since I wasn't sure if it was really all going to come together. So the next thing I want to do is clean all these things up and encapsulate them correctly so I can easily export this stuff to any new projects. I love clean, well encapsulated code. They never let you do things right in a real job, so at least in my hobby job, I want to write code that makes me happy. But other than that, the next steps are to start working on the debugging and editing features of the build. Things like running the simulation in slow-mo, going forward one tick at a time, moving pieces around, adding and configuring motion solvers, and so on. Oh, and also coming up with fun things to hunt, of course, and different challenges to put pressure on weapon design. Let me know how the video turned out in the comments. I usually try to stick to topics that are easy to find relevant footage for, but this time I just went with whatever I managed to get done and wanted to talk about. So I have no idea what I'm actually going to be showing on screen. Let me know if you prefer how I was doing things before, or if this is just barely watchable enough, and I hope you'll tune in next time.